Hey folks, welcome back. We're still looking at the PLC. It's the Delta PLC, and we are doing logic gates. Now, remember to make a comment, tell us where you are so we know how far we are reaching, so that we know if you are being appreciated out there. It is good to feel motivated. You know, it will be very motivating to hear people say whatever they say about to us as feedback, and probably room for improvement, suggestions. That would be welcome. Say it in the comments, and then also please do like to help with the algorithm. And then those of you who are yet to join us as a family, please do subscribe, so you are the first to get an update. Now we're still looking at the we said we're dealing with the gates, and we're using the WPL. We're using the WPL software. Remember, we open the thing there. We either open a new file through file new, or those who forgot, we could actually just click on the icon there, says new. As you can see, the other alternative is to just type Control plus N. All right. So I will click. You do whatever you're comfortable with, and now we need a toggle. And that toggle, let's name it. We are going to type there logic gates. We are still busy with logic gates. All right, now we need to select our PLC. By now we should know that our PLC is there, SS2. All right, and then what we then do is we then give a file name there. We are going to say we've done the other case, the buffer, the NOT, the OR gate, the AND gate. Now we're going to look at we'll do the OR gate and the AND gate. Now I'm going to look at the NOR gate. Let's look at the NOR gate, the NOR gate, the NOR gate. Now, all right. What we've seen so far, let's make our platform a little bit bigger. What we've seen so far is that we had an OR arrangement. Let me put one output that will be run by an OR gate, another output that will be run by what? By an AND gate. Let's have Y0 being run by the what? By the OR gate. Remember, the OR is simply a what? Let's say A or B. So remember, this is simply a what? An OR gate. There we put in our what? Our other normally open contact there. We call it X1, and then we say let's call it A or B. All right, and then this is B. So that's A or B. This is just telling us which components, which parts of the PLC did we use. The inputs there, we use the variable inputs, the X0 and X1, now to represent A and B respectively. Now what we are going to do is then we are going to say it has to be a parallel, so we need a line down there. So we're going to say line down, and then we can put our output there. Let's call it Y0. I can actually remember just say out, type out. When I type out, I just typed out in that space. You see what the blue box is? There, I just typed out. All right, and there we got out, and then we say out what output, and our output is Y0. So there you go. There you see, this is an OR gate, 2 input OR gate. There could be 3. You could make them 3 in parallel. There could be 3, and then I'm going to say, like I said, I'm going to do another one. Let's say X2 and X3. Let's rather say load, another way of thing. I'm using the instruction set now. Load, all right, X, because it's a variable input that I want to use, X2, and you can see it gives us the same. Now I want us to do the same normally open, but it's called X2. Let's give it a name. Let's say we're going to have A or B. What we're going to have here we're going to have A. Oh, no. Let's undo that. Control Z. Let's just go back and say I want a pen, but I want it much thinner for pen. All right. And the color, let's leave the color. All right. Let's say A. Is it clear? or B. Alright. We could have put a third one there, parallel, and it would have been or C. Alright, but we only have those two. Say A or B is equal to Y0. Alright. But then we also have here, I'm going to do an AND gate now, and that AND gate is going to be, we're going to call this one C. Alright. What I want there is to name this comment, call it C. Alright. Then okay. I'm using the comment to name here. Alright. So comment, that's a C. Alright, and then that will be what? That to be C or and D. I want to make it C and D, so this is going to be a series. We've done this before. It's a series. So I'm going to say load X3, so that X2 and X3, C and D. Let's call it on the comments there. Let me call it as D, so that we have C and D. This one is going to give us, let's take a pen. This is going to give us C, and it's represented by the multiplication sign, the dot product. C and D is equal to, this is going to be equal to what? Y1. So our output there is going to be Y1. So what we're going to do now, we're going to say on that, for the output here, we're going to call it out Y1. Y1. So I could have gone I could have used F7 there, or I could have clicked on this icon here, and then as you can see, that will all have given us that output there. The output is, let's call it, oh, I didn't call that one there. Let's say that one was F. Let's say this one is F2, because the other one, Y0, was F1. Let's go back and say this here was F1. We didn't name the output F1. Alright, function 1. Alright, so now, so what we have now is, we have, so instead of saying Y0 here, probably I should say, where's my eraser? I should say F1. If I name the other ones, I might as well name these ones. So this one is going to be F1. Oh, I want to write. So I'm going to say is equal to F1. I hope the yellow pen is visible there. And this one is equal to F2. So this is an OR gate. Okay. The plus symbol is used for OR. And this is a what? This is an AND gate. Alright. So what it means here is what? It means I want to then, this was okay. Besides being a reminder, I want to then, we want to do what now? We want to change the type of what? The type of what call this inputs. Instead of normally open inputs, we are going to rather say, instead of XOR being normally open, let's see what happens if we change these to normally closed. Let's remember, if we're going to use instruction, that's LDI. Okay, remember the instruction list. I said you can actually get the instruction list from what? From the help there, where you can go to help and go to PLC instruction and special register, and then you can have, or you can go through all those. We are going to, I said I'm going to get a special session to that. So for today, we do not want this. Now closing it. It is my picture. I don't know where I can see that. Yes. Now what I want to do now is change this to normally closed, and that one there to normally closed as well. So this is going to be LDI, or I could have just changed it LDI, and then I'm going to say okay. Now what you see here, we've got one. Someone will assume that since we've negated what we've done is we've used inverse inputs for the what? For the previous OR gate. Someone would expect this to be a NOR gate, but is it really a NOR gate? Let's see what happens. What I will do is I will also come to and do the same here. I'll do the same here and say, oh, by the way, when I do this, this is no longer true. This is no longer, if it's normally closed, it's no longer what? It's no longer OR gate. If it's normally, this is OR gate, but the moment I change this to normally closed, The moment I change this to normally closed by changing the instruction to LTI X2, and the same here, LTI X3. And now what I have is normally closed. It's no longer, this is no longer now a what? An AND gate. Let's see what it is. Let's suppose, let's bring a truth table here, no? I'm going to use a truth table, two truth tables. In fact, what I'm going to do is the one truth table. Let me rather get a black pen because this color looks suspiciously, I don't think it's clear. So let me just rather choose a black pen then. Let me rather come and say here, if we had A and B as inputs, I'm drawing the truth table in the space there. I could have the inputs as 0, 0, 0, 1. Go back to the case. If you can't remember this, we've got a very beautiful section on the case. And our output F1, we're going to check it now with the what? With the simulator. And also here, you could have A being. Oh, no. This is CD. This is CD. CD. Remember, this is C or Z and D. And it's 0, 0. That's the count 0, 0, 1, the count 1, 1, 0, the count 2, and 1, 1. Alright. And this is F2. Alright. Now, what then? Let's observe what happens here. It means these are set off. They are both off. If A and B are off. So what do we do? Let's simulate this. Simulate. Oh, I need simulate. Now, let's first check for errors. Debug. It shows you that because they are normally closed. Because they are normally closed, you see they are all active. Alright. Without us doing anything. If you look at the status there, if I right click on this, you see it is actually on when it's set off. When I set it on, it actually goes off. Why? Because that's a normally closed input there. Alright. So if it's in its normal state, which is the off state, it is actually looking like it's on. It is closed. Alright. It's a normally closed contact. Alright. So now, if they are both off, if they are normally closed contacts are both off, we've got the situation here. Alright. So let's simulate. Let's go and say, okay, get out of debugging. Let's go and say, put it online. And as you can see, it's on stop mode. We want to put it on run mode. Look at this. Yes, I want to check. You can see that all our outputs are on. Let's remember that this is set off, set off, set off, set off. And if for the off of, for this one here, you have an output. Oh, I need a pen. I first need to move that box. Alright. Get a pen. So you can see that when they're off, for both situations, you've got an output on the output. You can see your outputs are what? Your output Y0 is on and the Y1 is on. Alright. When all of them are off. Alright. What I'm going to do now is I'm going to change. I'm going to delete the first one first, because right now all of them are, I can actually come to this truth table and fill the condition for 0, 0, because all of them are what are in that state. But I'm going to start with this one and complete this table, and then go and complete the other one for Y1. Now let's look at this one here. If I come and change the status of this, alright, let me first check that. Yeah, alright. Now I come there and I say, why? Oh, didn't change. I come there and I say set on now. If I set it on, you can see because it's normally closed, it's gonna break. Alright. So but because B X1 is B, oh, what did I do? I started with the wrong one. I was supposed to set on B, but anyway, what I did was I went to the third condition there, which is setting on A and leaving B as it is. So power is still going through B and going out to our what? To our output. So I started with this condition there, so I'll go and say our output is still very much high. I need a pen. Our output is still high. What I meant to do, you can see now, I did this condition here. Alright. What I meant to do was set him on. If I set this one on, it will be Which one did I set on? Let me first see. I set this one on, yes, and I left this one off. That is that condition. Let's go to our second condition, which I omitted. This would be us coming here and leaving him off. That off. You can see it goes back on because it's normally closed. And then now, then we come and we say U, B, rather go on. All right. So on for B, off for A. So you can see you still receive power for the what? For our output still receives power through XO, which is A. So we still have power. So we are going to come there and say we are on. All right. And then finally we set both on. What we do, we come and you say, okay, the one that on there, come and say you must go on as well. Both of you are on. So as you can see, both of them being on means that that's the only time I don't have power. So what on that one? If I want power, I cannot engage both A and B. Not A and B. If it's A alone, I have power. If it's B alone, I have power. But if I engage both A and B, I won't have power. So for me to get power, I should not engage A and B. What does it mean? Not and for A and B. So therefore, this is what is called a not and gate, i.e. this is no output here, so it's a not and gate, all right, which is also the NAND gate. All right, it's a combination of not and. So it is easy to explain this using what? So what you see now, from our normally opens, which gave us an OR gate, we actually get an AND gate if we change them to normally closed. All right. So now then we'll go and say, okay, what about the other situation? What was previously with normally opens, this would have been an AND gate. Now we've changed the both inputs to what? To closed. And let's see. When both were off, as they are now, they are off, they've been set off, we can go and say, let's double check. Is this off? Let's set it off anyway, just to be sure. Set off. It was off anyway, stays like that. Set off. It was set off anyway, so it stays on. Because why? It's a normally closed, so power will go through under normal circumstances, right? Now then you go and you say, okay, I am going to change. So that condition is satisfied there. When they are both off, you get your output being on. All right. Now we go and say, let's change D and put D on. All right. We come to D and say, we are going to set you on. Now you see the D was closed, but when you set it on, it goes off, obviously breaking that line. And as you can see, doing it to X2 will do the same thing, but let's do it anyway. So we've broken D, we've engaged D, which was closed. Engaging it opens it, and it actually brought power to our output, and we have no output. Our output is off. Now we go to the third condition. Our third condition is U, D goes back off. So we go to D and put it off. We go to D and put it off. Just right click D there and set off, and you can see because it's normally closed, it goes back to its closed condition and it passes power. Now we come and say, but you, on the other hand, the C, we want you to be set on. And over setting on a a normally closed contact will put it off, therefore, but it breaks that line, therefore the power to the output goes off. So that there is power going off. I want a pen. Obviously, if a break means if a break means that it's a line, the circuit to be broken, breaking both of them will still keep the circuit broken. But anyway, let's do it. Let's act like Mamparas. And then just do it anyway. So we come here and say we set you on. set on, and obviously we've created another break. So we already had a problem of one break. We put 2 breaks, so there's no way that the power is going to go through. So there is our output staying off. What do you see? Previously we had, let me remove that. Previously we had a scenario where, so if both of them are broken, both of them are energized, it means that the output will remain off. So previously we had a scenario where, let me see if I can move this to a clearer. I want it to think, but anyway, it looks like I won't be able to move it. I wanted to have no crosses with the lines there, but anyway, I'm failing to do that, so it's fine. What we see now is when we have what was an AND gate with the open inputs, with the what was normally open inputs, when those inputs are exchanged for normally closed, we instead get, remember that the O situation was if any one of them was on, including the AND state, we had power. But if nothing was on, we didn't get power. This is the exact opposite. So this is what we call the NOR gate. All right. If any of them is on, we will not get an output. But it includes a NAND state. Remember, this was the NAND state. All right. So it includes a NAND situation. All right. So therefore, this is an inclusive. For the same reason that we had an inclusive OR, we now have an inclusive NOR state. So this is the inclusive NOR state. Let's take a pen and remind people, this is the second situation, the second rung is the inclusive NOR state. All right, so what have we done? We've done 5 gates now. We've done the buffer. No, we've done 6 gates. We've done the buffer. We've done the buffer, the NOT gate, which is also called the inverter. We've done the OR gate. We've done the AND gate. We've done in this episode here, I did both the NAND and the inclusive NOR gate. All right. Remember that all we did was also the inclusive OR gate. Let's bear in mind. Let's bear that in mind. So now I hope that was nice. If you really liked it, go and like it. Go and like it on the YouTube tab there, say you like it, and then please remember to tell us where you are on the comment section so we can see if we are growing or not. All right then, thank you so much. Remember to subscribe as well. See you in the next one.